Hello guys, Art-Teeves here. In this video, I'll cover the process of modeling, UV unwrapping and texturing this biomechanical walker house in 3ds Max, Rizom and Substance Painter. Let's get started. Quick heads up, like all of my videos, this one's partially unvoiced, so you can focus on the workflow. If you are finding this video useful, smash the subscribe button for more stylized content. Full timestamps are in the description and comment section below. Also, you can inspect the final topology on Sketchfab. I didn't want to upload a tedious 8 hours long video, so I've sped it up significantly. If you are using this as a beginner-friendly tutorial, I recommend watching it without sound and at 0.25x speed. I'll be using some very simple modeling techniques, which I'll explain in this intro. First, let me criticize my model a bit to highlight some limitations in what you are about to see. This house is more of a concept piece. If I were refining it for an actual game use, I'd create a separate interior, make the windows transparent, and add a matrix-style chair in the center with some food dangling from the ceiling. The door would of course be a separate openable object, and the chair would be scaled to match the size of a potential in-game character. As it stands, the house has a massive poly count of 17.7k polygons, quite excessive for a non-interactable static probe, even for an architectural piece. To optimize it, you could either severely reduce the poly count via manual retopology or simplification, or make it fully inhabitable and interactive, which would justify a higher poly count. The next step you would want to adjust in my workflow is preparing your model for animation. For example, it's best practice to model any bendable parts in neutral T-pose equivalent first, then add bones to create the deformation later. I won't be animating this house anytime soon. However, if I did want to animate it, I'd probably use the 3ds Max's cat helper system that has a spider rig. While the classic spider rig is designed for 8 legs, it can easily be adapted for our 5-legged house. The main adjustment would involve tweaking the leg faces during animation. I demonstrated a similar adaptation process in my SpiderBot character tutorial from a few videos back. Now let's discuss the poly count. For mobile games, the triangle ranges something between 500 to 2k trees. For indie games, I'd do something between 2 and 10k trees. For AAA games, the cap is somewhere at 50k polygons. If the house is interactable, operatable as a vehicle, like a moving house in Hall's Moving Castle or Mortal Engines, the cap would go up to 15k trees for a mobile game, 50k trees for an indie game, and over 100k for a AAA game. Obviously, these numbers are arguable. Anyways, let's talk about modeling now. My workflow relies on a strategic approach that combines Boolean operations with automated retopology. While this method can introduce some minor inconsistencies, the house's intentionally battered and damaged aesthetic means we don't need perfectly clean topology. Imperfections actually enhance the overall design. I start by cutting holes into an initial spherical base mesh, then experiment with different target poly counts during automated retopology. This allows me to refine the mesh until even the smallest openings maintain at least 6 to 7 sides, ensuring a balanced level of detail. The ideal number of sides for house holes, like windows, vents or damaged openings, depends on the balance between visual quality and performance. For clean shading, without excessive poly count, circular openings in structures should maintain 6 to 8 sides for distant assets, 8 to 12 sides for mid-range and 12 to 16 sides for hero elements. Note that the geometry I use for this house, especially the triangles, prevents me from simply adding or removing load variance. I create multiple separate side models using NURMS editing. What I especially like about this method is that it automatically generates spherical connection points with 16 sides, making it easier to connect models using splines. The main limitation, however, is that 16 sides is effectively the maximum number we can use for a hose or pipe. If you want to add custom models, you could use Boolean to subtract spheres or cylinders from them, then auto-retopologize the result. Adjust the number of iterations until you get a clean usable mesh. I use this method when modeling the side model that holds the house's left eye, as well as when shaping the feet of two long legs. Since I don't follow the traditional high-to-low polybaking workflow, my house could technically be classified as a mid-poly model. There's still significant room for optimization. For example, most wires and legs currently have 16 sides each, which could be reduced to 9 or 12 sides without sacrificing quality. I also use chamfers on most edges, which isn't ideal for poly count efficiency. Some of these details could have been achieved through painting or baking instead. The main advantage of manual retopology over the method I use for my model is the fact that you retain control of the exact amount of sides you get for each opening. This doesn't inflate your overall poly count. Also, you can simply intersect multiple models if you so desire. The module holding the left eye has 26 sides in its upper section, far more than necessary. And that's nothing compared to 65-sided monstrosity of the house's roof. Fortunately, both can be optimized significantly. All legs are designed for bone-based animation. They consist of long rubber joints that are reinforced with support loops to ensure clean deformation during bending. Surface details are later applied in Substance Painter. For rigid mechanical components, I recommend implementing them as separate objects rather than trying to integrate them into deformable geometry. This approach typically yields better results for hard surface mechanical movement. Yet I prefer to stick to simple and convenient biomechanical contraptions. Initially, I modeled the asset as a single mesh with only the left eye separated for animation, overlooking the need for symmetrical eye movement. Upon review, this was an oversight. The right eye must also be detached and rigged identically to prevent animation limitations. The real trick with models such as this one is balancing side counts. Enough for good shading, but not so many that we blow up the poly count. As I've mentioned before, we've got some obvious fat to trim. While it's not breaking anything now, this house is begging for proper manual retopology pass. I encircle most openings or intersecting seams between round elements with circular loops of near-square polygons. Also, it is a good idea to enlarge and exaggerate some elements like the gun, so that the model retains its overall cartoony design. That said, I should also note that my approach is a bit old-fashioned. Modern engines can handle objects with angons, and strategically placed triangles are generally acceptable. Each time you use the Boolean tool, it's usually best practice to isolate the components you plan to Boolean from the main model. Only apply the modifier to properly intersecting geometry, ensuring clean overlaps. This workflow significantly reduces potential mesh artifacts and preserves your model's integrity. Naturally, we should avoid adding small yet excessively detailed elements. For optimal animatability, I recommend modeling such things in simplified T-poses or neutral positions, and handling any bending or deformations during the animation phase rather than in the modeling stage. This model isn't using any load variance, so we're strategically employing triangles on flat, non-deforming surfaces, where they don't impact shading quality. My modeling process for this house involves a fair amount of preemptive planning and improvisation. Since I didn't use any reference images, I iteratively designed modular openings and connections, allowing different components to integrate organically as the model evolved. As I've mentioned in my previous video, this modular approach also offers some flexibility. You can easily swap out systems like weapons to create distinct variants of the same base model. Also, the single object approach isn't mandatory. We could certainly add external modules as separate objects even after filling all the pre-planned openings. That said, I personally prefer modeling cohesive assets like this one as single unified objects. My strategy wouldn't work if we wanted to create some transparent windows or openable doors. Also, it wouldn't work if we made arms or legs as rigid mechanical objects that are animated in a different fashion. Should you decide to add some separate objects, make sure they intersect each other naturally but never share any vertices or planes. This prevents Z-fighting. Z-fighting happens when two surfaces occupy the exact same space in a 3D scene. Since the graphics card can't decide which one to show, they flicker as they fight to appear on top. To optimize the model, I manually reduce the poly count and clean up edge loops using the loop regularizer script. When additional loops are needed, I often insert them while holding the Shift key. This forces 3ds Max to respect the existing geometry and maintain proper edge flow. This technique also helps reduce the number of sides in certain openings, for example by adding an edge loop between two existing loops and then removing its adjacent edges, allowing us to reach the desired poly count. For wires and hoses, we can strategically collapse edges along flat surface areas to reduce side edge count. Since these modifications occur on planar geometry, the introduced triangles won't impact shading quality. Exaggerating proportions of some elements allows us to preserve some kind of stylized comical look. Of course, the method I'm using for this model won't work as a standalone solution for highly complex objects like detailed curved vehicles. However, you can still leverage it by constructing intricate shapes from simplified models, combining NURBS modeling with auto-retopology. The main drawback of this method is its heavy reliance on hoses and other spline-based connectors which can quickly inflate the poly count. To optimize performance, try to keep the segment count of these hoses and wires as low as possible. Sometimes even 5 sides are sufficient. After completing this model, I finalize the smoothing groups and center it to the word origin 000 scene coordinates. Then I perform a thorough quality check, first hunting down any angons, polygons with more than 4 edges, then using the 3ds Max's X-View tool to identify problematic geometry like overlapping or isolated vertices and open edges. The complete model utilizes a single 4K Reso UV map with a padding of 32. All seams are strategically placed along hard edges, and UV islands are straightened in Rizom UV to minimize texture distortion. The layout maintains strict separation with no overlapping UVs. Actually, a padding of 16 can work. Also, 4K is a bit excessive for an object that is technically a static prop. Strategic UV seam placement is key. We can either position them along accessible edges for easy substance painter repairs with the clone stamp tool, or hide them in less visible areas. As an added solution, switching to triplanar projection in Substance Painter typically makes most seams disappear completely. Pay special attention to straightening all UV chucks containing wires. This will be essential for properly adding consistent details along their lengths in texturing. After normalizing UVs in 3ds Max, I perform manual scaling to allocate more texture space to visually prominent elements. Conversely, I reduce the size of UV chucks that will be obscured or less visible during typical use. When adjusting UV island sizes, make sure to maintain relative proportions within the same object. It's generally good practice to keep UV size variations within 20% of neighboring elements. Always scale UV islands uniformly per element. Any uneven scaling will create visible seams that Substance Painter can't fix no matter what tricks you try. Before you send your model to different software, remember to reset its rotation angles, pivot points, scale, and X-form. Finally, I resize some UV chucks I want to resize and repack the model in Rizom. Then I return to 3ds Max and use its X-View tool to scan my model for some overlapping UV chucks. That covers everything I wanted to share about the modeling and unwrapping process. I'll pause the narration here and continue with the voiceover during the texturing section. For your reference, the video's table of contents is available in both the description and the comment section below. And I'm back. Since I didn't use the classical high to low poly baking pipeline, I've used a simple universal set of baking parameters that apply to almost any baking process. I've set the highest possible amount of phrase on all tabs, which didn't change much since we aren't baking anything right now, disabled the ID section, and set subsampling to 16. Also I've set my ambient occlusion to same named meshes only, to not to ruin the eye, which remains a separate object. Texturing this house relied on modified smart materials. I start by applying a default steel and increasing its roughness value. This layer will mostly be visible on edges. Also I've reduced its luminosity slightly. Next I create a rust layer and apply grunge scratches dusty to it. This layer is inverted. The scratches grunge is subtracted from previously added gun edges smart mask. We use anchor points to control layer intersections and create an illusion of paint towering above scratches. I also apply a high pass and layers filters to it. If you are new to Substance Painter, there is a great video called Learn Everything About Substance Painter by Production Crate, where he explains some really nice things about creating your own smart materials and playing around with some settings you may encounter in my pipeline. I didn't want to repeat his video. I layer two variations of our base material to create a weathered paint effect. This multi-material approach mimics natural wear patterns, giving our house those spots of aged and chipped paint. At this stage, you can experiment with different grunges or smart masks. I copy the folder with material I've created and use its altered versions for metal parts of legs and also the window frames and the door itself. The fourth version of this material is applied to the wall on the rear side of the house. For rubber hoses and joints, I use the Rubber Dry preset smart material. Next I copy it, make the copy darker, apply a black mask to it and fill it with stripes, while playing with its rotation angle and tiling. As I've mentioned in my previous video, setting projection mode triplanar hides most visible UV seams. Remaining seams can normally be hidden manually by using a paint layer that has all of its blending options set to pass through, and also by using the clone stamp tool. To maximize its efficiency, you can play around with your clone stamp tool's flow or create multiple layers with different opacity settings. For lamps, I enable the emissive channel in the texture set settings menu and add the light emission to glowing elements and dark emission for dust and dirt. Before adding detailed layers, start by applying a uniform base material across your entire model. This ensures no surfaces remain accidentally untextured and provides a consistent foundation for subsequent weathering effects. Make sure to play around and change your environment settings now and then. Also, remember to rotate light sources, because altering the light will change the looks of your model dramatically. Switching between different environments gives you an idea of how your model will look in different conditions. For all emissive components, fully paint their base colors in your texture work. This ensures proper visual continuity when emission maps are disabled during rendering or gameplay. I establish a ground gradient layer for the legs and body, then incorporate additional grunge passes. In my experience, you can never have too much weathering. There's always room for just one more grunge layer to achieve that worn-in look. This covers everything I wanted to mention. I'll stop narrating at this point. Thanks for watching, guys. If my videos are of use to you, be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.